Okay, so if you've been paying close attention here, you can see that we've worked our way through almost all of our learning objectives here. We are just left with identifying an acid and writing the chemical formula and naming acids as well. So pretty straightforward. We're going to do our last little bit here. Let's get going. So what are acids? So acids are like a very special case of molecular compounds that exist specific behaviors. So acids are molecular compounds, but honestly, they kind of act like ionic compounds in the end. So they form H+ ions when dissolved in water. So it's kind of like how ionic compounds form ions when they're dissolved in water. So there are many definitions of acids and bases, but this is just the definition we're going to use for now. That acids form H+ ions when they are put in water. We'll have a whole chapter on acids and bases in chapter 14. So again, we might think of these acids as almost like hybrid, quote unquote, of ionic compounds and molecular compounds because they break into these H+ ions and then whatever the anion they're connected to, so they kind of exhibit that behavior. So the book will call acids with the aqueous state. So anytime the book's going to talk about hydrochloric acid, it's going to say HCl parentheses aqueous. However, we're going to worry more about this in chapter 7. For right now, I'm going to have a specific way we will identify acids separately. So this is called the aqueous state. It's meant to say that a substance is dissolved in water. So if you ever see the parentheses AQ, all that means is that whatever the substance is, it's been dissolved in water. So again, we'll talk a little bit more about that later, but just so you know, that's what the book means when you see that AQ. So how do we know we have an acid? Well, an acid has a chemical formula that starts with hydrogen in it. So that's how we are going to identify our acid. So it's either going to have acid in the name, or it's going to have a hydrogen at the front of its chemical formula. Remember, a lot of times hydrogen is not the first element that we write when we're writing molecular compounds and when we look at our list. So it's a pretty big hint to us that if we have an H out front, we have an acid. So take hydrochloric acid, what I've pictured here on the screen for you. So you can see it's got its little H+ ion and it has the chlorine anion. So yes, it's a molecular compound, but this is another way you can think of it because this is what it's going to break into when we put it into water, which is something that's very important when we talk about acids and bases. And again, we'll talk about when we get to chapter 14 on acids and bases. So let's talk about some steps for naming acids. So it's pretty straightforward. You just look at the anion part, you look at the part that isn't hydrogen, and you identify the anion and you name it from there. So identify the anion. Is it a singular atom? Is it a polyatomic ion where the name ends in ate? Or is it a polyatomic ion where the name ends in ite? Okay, so there are just 3 different cases here. So we have 3 different naming schemes based on these 3 different cases. So if the anion is just a singular atom, it's not a polyatomic ion, it's a monatomic ion, we write the hydro prefix, we write the base name of it, and then we write the ic ending. So we end up with like hydrochloric acid. That's how we're getting the naming scheme. Hydrobromic acid, hydroiodic acid, lots of different things there. So if your anion is a singular acid, you take the hydro prefix, that base name that we got from the anion names, with this ic ending, okay? So hydro whatever ic acid. Not too bad. When we look at step 2 here, we might have an anion that is a polyatomic ion. So we'll only look at how to name these acids if our polyatomic ion has an ate ending or if our polyatomic ion has an ite ending. So we're not going to look at all these other cases. We're only going to look at these 2 here when we're naming our acids. So we look to our anion. If our anion is a polyatomic ion with the ate ending, I write the base name of that polyatomic ion with the ic ending. So it gets a little confusing between step 1 and step 2 because we're adding the ic ending and the word acid in both cases. However, if it's a singular acid, it gets the word hydro. If it's an acid with a polyatomic ion in it, it just gets the ic ending. It does not get a prefix, okay? So that's the difference here between step 1 and step 2 is if you have a singular monatomic anion, you have the hydro prefix. If you have a polyatomic ion as your anion, you use the ic ending with no hydro prefix, okay? So this might be sulfuric acid, carbonic acid, I can't think of any other polyatomic, nitric acid, for example. I was trying to think of all the polyatomic ions that end a day with a. So those are some examples of those there. So that would be like nitrate, sulfate, carbonate, chlorate, those kinds of things. So we also have the case where we might have a polyatomic ion with an ite ending, okay? So an ite ending. So we have the ate ending ate, and we have the ite ending ite. So this would be sulfite, nitrite, chlorite, those kinds of things. They get an entirely different ending. So they take the OUS ending. So we've got nitrous acid, sulfurous acid, those kinds of things. So that's basically what our naming scheme is going to look like. You look at the anion that's attached to the hydrogen and you name the acid based on that anion. So let's go ahead and look at some examples. All right, so let's go ahead and work through some examples of how to name acids. So I've got 3 different acids written up here on the screen. We know that these are acids because they all start with hydrogen. The only case that we're going to see where we're going to start with hydrogen and it's not going to be an acid is our buddy, dihydrogen monoxide, water. So if you see water, you should be able to name water as a general molecular compound. However, again, acids are a more specific type of molecular compound. So we're going to name them like they're acids. We see that they all start with hydrogen. We're going to follow the acid naming scheme, okay? So first acid, I see that I have H2S. So H2S is going to be named this way. So remember, when we look at acids, we look to the anion to do all our naming. So we have to first decide, is our anion a monatomic ion, a polyatomic ion, and then if it's a polyatomic ion, we have other rules to worry about, okay? So is it monatomic? Is it polyatomic? Well, I see only one sulfur atom there. I would say that is monatomic. So I have a monatomic anion, so I follow that naming scheme where I have the prefix hydro, the base name, and then I have the name acid. So I would call this hydrosulfuric acid. So H2S is hydrosulfuric acid. Again, we get one single S, so that means we follow the hydro prefix with ic suffix rules. We take that base name of sulfur, so we say hydrosulfuric acid, and then hydrosulfuric, and then we write the word acid. So we have hydrosulfuric acid in this case. Okay, so when we look at, when we look at the second acid on the screen, if you didn't already see the name because I put the answer up on screen, we have H2SO4, okay? So we're looking at H2SO4. So when I look at this, I see I have an acid because it starts with hydrogen, and then it's followed by a polyatomic ion. It's not followed by a monatomic ion, it's followed by a polyatomic anion. So therefore, I look to see what my anion is, and I name it based upon the name of the anion, okay? So I look to my polyatomic, and I name it based on the name of the polyatomic anion. So I have sulfate. If it has an ATE ending at the end of the polyatomic ion name, an ATE ending at the end of the name, you change that ATE to an IC. So this was sulfate. This becomes sulfuric acid. So you always write the name acid at the end of an acid. So it's pretty obvious when you have the name, you have an acid. But we see sulfate, so it takes an IC instead of the ATE in the name. So we have sulfuric acid. So sulfuric acid is H2SO4. So this is the anion sulfate. Again, we see there, we have the base name of sulfate, which is going to be it without the ATE, so SLUFUR. So that we would say as sulfuric acid. We add the ic instead of the ate. So sulfuric acid. There's a fun little, rhyme that chemists often use to remind students in lab or remind ourselves as well, that things that look like water can be very dangerous as well. So H2SO4, if you had a beaker of water and you had a beaker of H2SO4 and you sat them next to each other, you wouldn't be able to just look at them and tell the difference, okay? So the rhyme is, Johnny was with us, but Johnny is no more. What Johnny thought was water was H2SO4. It's something close to that. So what he thought was water was actually H2SO4. We know that when we look at H2SO4, we can now identify that that's an acid, and I will say sulfuric acid is one of the stronger ones that we tend to deal with. HF's probably the strongest acid that chemists kind of use in general, and nobody uses HF. Let me tell you, that's a scary one. I sure as heck haven't even probably been in the same building as HF. Well, maybe at Michigan State, but with H2SO4, that's going to be one of the strong acids that we'll actually kind of encounter and that you may encounter outside chemistry as well. So that's sulfuric acid, H2SO4. Well, what about H2SO3? Okay, so if we check that one out, we see that we have the sulfite polyatomic ion instead of the sulfate polyatomic ion. So we have to change the ITE to OUS. So we see sulfate or sulfite, so therefore sulfite becomes sulfurous. Sulfite becomes sulfurous. So that's the way that's going to work. So if you see an ITE ending, it becomes OUS, add the word acid. So again, we see that the anion is sulfate. We have the base name of the polyatomic ion, add the OUS ending, so this would be sulfurous acid. Sulfurous acid. Sulfur's got kind of a weird base name thing going on there, but sulfurous acid. So I'm going to leave you with some practice on some naming skills as well here. So check these out. See if you can name them. I've got the answers here in the PowerPoint for you. So let me know if you have any questions. Go through, try naming these, get yourself some practice. All right, so last thing here, we have to write our chemical formulas of our acids. So the idea is, remember, we're going to take the name and we're going to be able to write the chemical formula from the name. So writing the chemical formula of an acid might actually feel more like writing the chemical formula of an ionic compound, unfortunately. So we sort of have these H plus cations. We can kind of consider them like cations with these anions. So we want a charge neutral formula just like an ionic compound. So we have to have enough H pluses to balance out the charge from the negative anion. So you look at the anion, you determine the charge on the anion, and you determine or you balance the total number of negative charges with H plus ions. So let's talk about some steps on how to do this. So again, you look to the name to determine what your anion is. So if you see that hydro prefix with an ic suffix, you have a singular atom. If you see the ic suffix with no prefix, you have the polyatomic ion that ends with 8 that has that base name. If you see the OUS ending with no prefix, you have the polyatomic ion that ends with the ITE ending, okay? So we're just kind of going backwards. Before, it was look at the anion, figure out the prefix suffix. Now we have to get the information from the prefix and suffix to determine what the anion is. So once we've figured out which anion we have to figure out what the charge is on the anion. Of course, as we've talked about, all of the anions have known set charges. We know that. So once we look at our anion, we know which one we have. We need to determine the charge on the anion. So once you've determined the charge on the anion, that determines how many hydrogens you have. So you need the same number of hydrogens as you have total negative charges. So if you have something with a 2 negative charge, you need 2 hydrogens. If you have a 3 negative charge, you need 3 hydrogens. If you have a 1 negative charge, you need 1 hydrogen. Straightforward. So you write the H with the correct subscript depending upon your amount of negative charge, and then you write the name of the anion. Anions in this case are always going to have a subscript of 1 because we're using the hydrogens to balance the anion. We're not trying to add more copies of the anion in or anything. So again, in summary, use the name to determine which anion you have, figure out the charge on the anion, and make that the subscript of the hydrogen. So let's do some examples. Let's work these examples to practice writing chemical formulas of acids. So let's start with number 1 here. What is the chemical formula of hydroiodic acid? So the first one here, hydroiodic acid. So I look at the name and I determine whether it's the monatomic anion or if it's the polyatomic ions, and then I go from there. So I look to the name. I see that I have the hydro prefix. You can basically stop when you see the hydro prefix. You know you have exactly the monatomic ion. So if we have iode, that's iodine. So if I have one singular iodine, it has a charge of -1. So that means that becomes the subscript on my hydrogen. However, we never write a subscript of 1. So I've got hydroiodic acid as HI. Hi. So hydroiodic acid, it's kind of like the hello molecule. So it's HI. We see that hydro prefix with the ic suffix, so we know we must just have the monatomic iodide anion. Iodide ions always take on that 1- charge, so that hydrogen atom gets a subscript of 1. We write HI. Not that bad. Let's do the second one. So on the second one, I see that I have chlorous acid. If I do not see the word hydro, or I see the prefix of hydro, I can look at that and I can say, okay, that means I've got a polyatomic ion. Now I need to figure out which polyatomic ion I have. If I see the OUS ending, that means my polyatomic ion ends in ITE. So this is the chlorite ion. So first things first, I look at chlorous. I see OUS, that means ITE, chlorite ion. And the chlorite ion always takes on a charge of 2-. So if the chlorite, all right, so let's go ahead and work through our second example here, sulfurous acid. So I'm looking at sulfurous acid. I do not see the hydro prefix. So that tips me off right away if I don't see the hydro prefix that I have a polyatomic ion. So I need to figure out if it's the ITE ending or the ATE ending on the polyatomic ion. So if I have sulfurous acid, I see that I have the OUS ending. If I have the OUS ending, that means my polyatomic ion ends in ITE. So this means I have sulfite. So if I have sulfite, I know sulfite always takes on a charge of 2-. So that becomes the subscript for my hydrogen. So I have H2SO3. H2, you write the name of the chemical formula of the polyatomic ion, H2SO3 for sulfurous acid. H2SO3. So we got the OUS ending. We saw that means the ite polyatomic ion. So if you have the ite polyatomic ion, we know sulfite has a charge of -2. So H2SO3. Okay. And so what is the chemical formula of acetic acid? Okay, so what's the chemical formula of acetic acid? Well, we see the words acetic acid. We do not see the word hydro anywhere at all. So we don't see the word hydro anywhere, so we just have acetic acid. So we look to the name to figure out which polyatomic ion we have if we don't see the hydro prefix. So we see that we have an IC ending, which means our original polyatomic ion ended in ATE, so that means I had the acetate ion to make this acid. So I have to figure out what the charge on acetate is, and then I can use that as the subscript for my hydrogen in this case. So acetate is C2H3O2 with a 1- charge, so that means I only need 1 hydrogen. So HC2H3O2. So we don't combine the H's. We want to leave the H out in front because it is showing that it's an acid. So if you're writing the chemical formula of acetic acid, we don't write C2H4O2. We write HC2H3O2 because this gives us an acid-style chemical formula. So our chemical formulas are always going to start with hydrogen if we have an acid. So we see the ic suffix, we see no hydro prefix, which means we have the ATE ending. So we have acetate. So the acetate ion always has a charge of -1, so I only need one H atom. So I have HC2H3O2. So that is acetic acid. So that is what I have for you about writing the chemical formulas of acids. There are some practice problems here as well. Please work through them. I beg of you, ask me questions if you have them, please. So let me know if you need anything, and that's chapter 5.